let's now talk about differences between virtual machines and Docker containers. And there are actually advantages and disadvantages of using either virtual machines or Docker containers. And in different cases, you should choose different options, either go on with virtual machine or use Docker container. And I'm sure that you have used before virtual machines a lot. And the virtual machine is basically an option to create a server with another operating system that differs from underlying operating system of the computer where virtual machine is running. For example, you could create a Mac OS virtual machine on Windows computer, or in opposite way, you are able to create a Windows virtual machine on Mac OS computer. And also very often virtual machines are used in the cloud hosting services, and you are able to rent a virtual machine for just a few dollars per month, and you will get access, for example, to any Linux-like system, and you are able to host your website or something else there. Alright, let's now dive more into details and talk first about virtual machines architecture, and also I demonstrate you how I personally use virtual machines. Alright, let's get started. Alright, let's start discussion about differences of virtual machines and Docker containers from talking about architecture of virtual machine. And let me first explain you this diagram, and afterwards I'll show you how I personally use virtual machines. Alright, so if you want to create a virtual machine, you should have either physical server or virtual server. It is basically possible to create virtual machines inside of other virtual machines. And there is host operating system. Host operating systems could be different, for example, either macOS, Windows or Linux, any operating system. Afterwards, on top of this host operating system, you should install so-called hypervisor. Examples of such hypervisors are following: VirtualBox, it is free and open source; VMware Fusion, for example, that is used on macOS, or VMware ESXi. And VMware ESXi is basically installed directly on the computer. It doesn't require any other host operating system. It means that there could be scenarios when hypervisor is running directly on physical server or other virtual server. Alright, on top of hypervisor, you are able to create virtual machines. And notice that main key idea here is that every virtual machine has its own guest operating system. And that means that you are able to create different virtual machines with different guest operating systems on another physical computer that is running different operating system. For example, host operating system could be Windows. Guest OS here could be Linux, guest OS here could be Mac OS. And every virtual machine has, of course, its own set of binary files, executables, own file system, actually dedicated resources like CPU, memory, hard disk, and so on. And of course, inside of every virtual machine, you are able to run applications. And every application inside of every virtual machine will be, of course, isolated from applications in other virtual machines. We could say that every virtual machine is a separate world, separate entity. And that means that if you want to get a complete separation of computers, virtual computers, you could of course use virtual machines, and you should use virtual machines. Alright, let me now demonstrate you how I personally use virtual machines. Basically, this computer that you see right now, it is Mac OS computer, it is actually virtual machine. And this virtual machine is running using VMware Fusion Hypervisor. Also on this computer, basically my main computer is macOS computer with 16 GB of RAM. I also run other virtual machines on the same computer. And here, for example, you may see Ubuntu virtual machine. Here you could see Windows virtual machine. And again, all those three virtual machines are currently running on single physical Mac OS computer. Let me quickly demonstrate you how actually this looks like in terms of VMware Fusion and how actually resources are split across different virtual machines. But let me do that after the small pause. See you next. Bye bye. Alright guys, now you understand the main idea behind using virtual machines. And it is that every virtual machine has its own guest operating system that of course may differ from underlying operating system that is used on main computer where virtual machines are running. And also usually every virtual machine has its own dedicated resources, like dedicated amount of memory, dedicated CPUs, and dedicated disk space. And now let me do for you quick demo and show you how I personally use virtual machines for development and for recording of those courses. Alright, I use VMware Fusion. It is hypervisor for Mac OS. And basically at the end of a previous lecture I have shown you that I currently run 3 different virtual machines: Mac OS, Ubuntu and Windows. Of course, usually I don't run those virtual machines in parallel, and sometimes I stop 2 of them and run only single, for example Mac OS, or when I need, for example, Windows virtual machine, I start it and stop Mac OS. But it is of course possible to run all of them simultaneously. But I'll show you just in a moment what will happen if I'll start all of them simultaneously. My Mac OS will be actually almost out of memory. Alright, let me go to this page where I have actually list of virtual machines that I'm currently running. It is Mac OS again, Windows and Ubuntu. And let me quickly demonstrate you settings, for example, of this Mac OS virtual machine. Go to settings and here go, for example, to processors and memory. And you'll see that this particular virtual machine has 2 processor cores assigned, and also it has 8 GB of RAM. There are also advanced options like enable hypervisor applications in this virtual machine, enable code profiling applications, and so on. With this option, for example, I'm able to create virtual machines inside of this macOS virtual machine. Alright, let's go back, for example, to configuration of disk. And here you see that I have assigned 46 GB of disk storage to this particular virtual machine. And all files for this particular virtual machine are stored in this VMDK file. Let me actually quickly go to this VMDK file and show its structure, and basically except this VMDK file there are a bunch of other files. Let me show in Finder files for this macOS virtual machine, show package contents, and here you may see list of files for this particular virtual machine. And basically there are a bunch of different configuration files, cache files, log files, and so on. But the main files are here, this VMDK file and this one. Actually, I'm running here Catalina Mac OS operating system, and it actually uses 2 different disk drives, one for operating system and second for remaining files. And that's why here I see 2 different VMDK files. Also, it is possible to create so-called snapshots of virtual machine, and you see that there is single snapshot that actually also takes some amount of disk size. It is almost 9 GB in size. It is possible to create multiple snapshots and go back to a particular moment in time using snapshots. Alright, that's how disk looks like for this particular virtual machine. And total size of Mac OS virtual machine is 65 GB. It is of course larger than specified here in settings. Let me go to settings back, and actually again limit that was set for this virtual machine is 46 GB. Alright, let me also show you other settings like network adapter. You are able to add multiple adapters if you want, but here you see option share with my Mac, and in such case virtual machine will share IP address of my main computer. Next, you are also able to set some configuration parameters for display and so on. Alright, that's settings for this particular virtual machine. I could also quickly show you settings for this Windows virtual machine, and I have configured for it 4 GB of RAM and also 2 processor cores. Alright, but now let me demonstrate you how many resources are actually used at the moment at my main computer. And for that, let me open up Activity Monitor and go to Memory here and filter by VMware. And actually you'll see main VMware Fusion process. Here it is. It takes almost 300 megabytes of RAM, but also you'll see three different VMware VMix processes. This one, and this one. And basically at the moment every of those processes is responsible for running of separate virtual machine. And I have just shown you that I have allocated 8 gigabytes of RAM to macOS virtual machine, and that's why here you see this process that actually takes this amount of RAM, 8 gigabytes of RAM. And here next you see Windows virtual machine, and it takes 4 gigabytes of RAM. And last one is Ubuntu, and I have allocated to it just 2 gigabytes of RAM. It's pretty enough. Also, let me go to CPU tab, and also on this tab you'll see three different processes that are currently using some percentage of my main CPU. For example, this one is using at the moment 16% of my main CPU. That's how it looks in terms of resources consumption, and basically if I'll have a look again at the memory, you should see that my physical amount of memory on this computer is 16 gigabytes, and almost 13 gigabytes of RAM are currently utilized by those three different virtual machines. That's why it means that I'm not able to start three additional such kind of virtual machines, because my computer will be simply out of memory. Alright, also let me demonstrate you quickly that I have also access to ESXi server, that is actually hypervisor that is installed directly onto the server. And it is actually a remote server, and here on this server you may also see some virtual machines that are present there. For example, I'm able to access Ubuntu virtual machine, and I'm able to open it up and log into it remotely. Same I can do with any other virtual machines on this computer. Alright, let me also show you that you are also able to perform different management tasks with every virtual machine. For example, I could suspend virtual machine, I could stop it, I could reload it, I could create a full clone, and of course you are able to move virtual machine from one computer to another. And on production services like VMware ESXi servers, you are able to automate all those tasks. You are able to create, let's say, 10 clones from particular virtual machine. You could move machines from one server to another. You can scale machines and so on. It is really nice production solution. Alright, that's all for this demo. I hope you liked it, and the main idea that I wanted to transfer to you is that every virtual machine first has its own guest operating system, and second has its own resources. And I have shown you that if I allocate particular amount of RAM to particular virtual machine, then this amount will be forever reserved at my main computer. Forever, I mean while virtual machine is running. As soon as I stop it, of course, those resources will be freed up. It is also possible to create virtual machines that actually share resources, share CPU resources and share RAM. And such approaches are very often used by hosting providers like Amazon, Google Cloud or DigitalOcean. And you are able to buy either virtual machine with dedicated resources, dedicated CPU, virtual CPU, dedicated memory, or you are able to buy so-called virtual machine with shared resources and share RAM and CPU with other virtual machines. Such virtual machines are usually much cheaper than machines with dedicated resources. Let me basically quickly show you that, and let me go, for example, to DigitalOcean. And here go to products and droplets. Every server here is called actually droplet. And if you'll scroll down a bit, you could see that there are so-called standard droplets, and they share CPU with other droplets, and there are dedicated CPU droplets that have 100% dedicated virtual CPUs, along with balanced memory. Alright, that's how it looks at hosting services, and again, most companies, most hosting services are using nowadays virtual servers instead of dedicated servers, and almost no one uses so-called bare metal or dedicated servers, I mean servers with physical memory, physical CPU resources and so on. Because of all advantages of using virtual machines. They could be easily scaled, migrated, copied, cloned and so on. Alright guys, I hope that you enjoyed this quick overview of my setup and now you completely understand what is a virtual machine and what are advantages of using virtual machine. Let's now proceed and next let me talk about architecture of Docker and advantages of using Docker and of course about disadvantages of using Docker. I'll see you next. Bye bye. It's funny guys, but just after recording of the previous lecture, when I have started 3 different virtual machines simultaneously, my computer ran out of memory and I was actually recovering from that state for maybe 10 minutes. And I got this message. I also got crash messages in all 3 different virtual machines. And still I can see that Mac OS virtual machine process is taking around 200% of my CPU. And it seems that I need to reload virtual machine in order to fix that. That's, guys, what happens when you run multiple virtual machines on a single computer. You could simply go out of memory or out of hard disk. Actually, I got that notification as well that my computer went out of disk storage and I needed to clean it up because probably some virtual machines have written additional files to hard drive. That's actually what happens and that is a real case. I have not simulated it. I got it actually first time because before I have not run multiple virtual machines in parallel. I have done that just for demonstration for you. Alright guys, let's proceed and next let's go on with Docker and I'll explain you architecture of Docker. Okay guys, let's proceed with discussion about virtual machines and Docker containers and the differences between them. And we have before discussed advantages and disadvantages of using virtual machines and I have made for you a small demo. Now let's go on and let me demonstrate you now this diagram where I have outlined the structure of Docker and Docker containers. First of all, there is the same as with virtual machines, physical server or virtual server. Next to it there is host operating system, like Mac OS, Windows or any other Linux-like system. Next there is Docker engine. And on top of Docker engine there are containers, and on this diagram there are 2 containers, container 1 and container 2. And notice that main difference of this architecture from architecture with virtual machines is that the containers don't have their own guest operating system. They have only binary files, libraries and some applications that are running inside of every container. But again, main idea is that there is no guest operating system. And of course, out of this fact comes the conclusion that containers somehow need to use underlying operating system. And that is the responsibility of Docker engine to perform such communication between containers and underlying operating system, host operating system. That's how containers are structured basically. Alright, let me now show you how Docker desktop looks like on this computer. I have actually installed it and you should have also installed Docker on your computer. If you have Mac OS or Windows, you should have Docker desktop, and if you have Linux-like system, you should have installed Docker engine directly on your computer. Alright, let me go to this icon and I see that Docker desktop is running right now, and let me go to dashboard here. And on the dashboard, let me open up settings, click on this icon and go to resources. And here on this page I see resources that were allocated to Docker on my macOS computer. And I see here amount of CPUs, 1 CPU, and amount of memory, RAM. And there are just 2 GB of RAM allocated to Docker. There is also swap size equal to 1 GB and the total disk image size is 60 GB. And at the moment only 9 GB out of 60 are utilized. These are resource limits for Docker setup on my computer. And now question, what if I run, let's say, 10 containers on this computer using Docker? How many resources will be utilized by those containers? Answer is very simple. Here are limits. In total, all 10 containers cannot use more than 2 GB of RAM and more than 60 GB of hard drive space. These are limitations for all containers that you could run on your computer. And it means that all containers basically share resources that were allocated to Docker. CPU resources, hard drive resources, and memory resources. And that is the main difference between virtual machines and Docker containers. And of course, you are not able to run inside of the Docker container, for example, Mac OS operating system or Windows operating system. It is not possible at all. Because again, as I have just shown you, Docker containers don't have their own guest operating systems. They have just processes that are running on top of host operating system. That's it. But now you may ask me a question. How it is actually possible to run containers on Mac OS, on Windows, and on Linux? I'll answer this question in the next lecture, but before wrapping up this one, let me quickly go to Activity Monitor and show you actually how many resources are utilized at the moment by Docker on this computer. Activity Monitor. And let me filter all processes by keyword Docker. And here on top of this list you see a process called com docker hyperkit, and it currently uses around 2 GB of RAM. And that's exactly that amount that was assigned to Docker in Docker settings. Let me basically quickly go to Docker setup, go to dashboard and settings and try to increase this size. Go to resources and let me make it, let's say, 3 GB and apply and restart. Alright, Docker was restarted. Let's close this window and go back to Activity Monitor. And now I see that Docker hyperkit is utilizing around 3 GB of RAM. Except this process, you see here such processes as Docker, com docker VPN kit, com docker backend, supervisor, and OS6FS. And all those processes are actually for interaction between Docker engine and my main macOS computer. Alright guys, that's all for this lecture, and the main outcome is that every Docker container does not have its own guest operating system, but has own processes and doesn't have own resources. All resources are shared between all containers. Next, let me explain you how Docker containers could be running on different operating systems like Windows, Mac OS, and Linux. I'll see you guys in the next lecture. Bye bye. Alright guys. Now you know differences between virtual machines and Docker containers, and main difference is that virtual machines have guest operating systems, and usually every virtual machine has dedicated resources like CPU, RAM, and hard drive. Docker containers don't have own guest operating system, they rely on host operating system, and they also don't have dedicated resources. They share resources that were assigned to Docker engine. Alright, let me now explain you how actually Docker containers are running on host operating system. And let me show you this diagram. And on this diagram you see Linux as host operating system. This machine has some resources like CPU, RAM, disk, and network. There is also Linux kernel. Inside of this Linux machine there is Docker engine installed. And thanks to Docker engine, now you are able to create different containers inside of this Linux machine. And all those containers will be sharing those resources. Actually, you could limit resources that could be allocated to all containers, and of course they should be less than this machine has in total resources. I mean, if this Linux machine has, let's say, 8 GB of RAM, you could assign to Docker containers just 2 GB or 3 GB. And again, all those containers will share those resources. Share disk size, share access to network, share RAM, and share CPU. It is possible in Linux operating systems because in Linux it is possible to group resources per process or per group of processes. It is not possible to do in macOS, for example, but it is possible to do the same on Windows computers, and it is possible to create Windows containers. But in this course, I will not talk about Windows containers because at the moment they are not so often used, and I will primarily focus only on Linux containers. And again, main idea behind all of this Docker setup is that it is possible to group resources CPU, RAM, disk network per process inside of container, or per group of processes inside of container. For example, you are able to run 10 different containers with Node.js process, and every container may run different versions of Node.js. Or you are able to create 10 different Nginx web servers in 10 different containers, and again use different versions of Nginx, different set of HTML files, JavaScript files, and so on. Again, it is possible due to separation of processes inside of the Linux. But now question, how is it possible to do the same on macOS computer or Windows computer? It is possible if you'll create very small, tiny Linux virtual machine inside of macOS or Windows computer. And in such case, picture will be exactly the same, but this Linux virtual machine will be running all containers inside of the Mac or Windows computer. That's that simple. Alright, let me now explain you how actually containers interact with Linux kernel and use resources on Linux computer. But again, main outcome from this lecture is that containers, Docker containers, are running inside of the Linux machine. And if you set up a Docker desktop, you install actually tiny Linux virtual machine on your Mac OS or Windows computer. Alright guys, let's proceed, and next let's discuss how Docker processes interact with Linux kernel and use resources. I'll see you in the next lecture. Bye bye. Now you know that Docker containers are running actually at Linux host operating system. And if you install Docker on Mac OS or Windows, you install application called Docker Desktop. And it actually creates small Linux virtual machine, and inside of that small Linux virtual machine, containers are running. Let me now explain you more details about how containers processes interact with resources like CPU, RAM, and memory. Here on this diagram you see Linux host virtual machine. Every Linux has Linux kernel, and it has usual resources like CPU, RAM, network, and disk. If you install Docker engine on Linux, it will actually install some processes that will be able to create separate resources like separate disk space, separate processes for every container. And it's possible in Linux due to namespacing. Namespacing allows you to create separate users, separate processes, separate spaces on hard drive that will be completely independent from each other. And on this diagram you see that every container, this one, and this one, have separate space on hard drive. And there are separated container 1 files, container 2 files, and container 3 files. Before going on, let me actually ask you a question. What is actually computer? Computer is basically a set of hardware like CPU, memory, hard drive, and network interface or interfaces, and a set of files. Nothing else. And when you power on computer, some of the files become actual processes that start in memory. And afterwards, processes are running, they access hard drive, access memory, access CPU, create additional files, and so on. But in a nutshell, every computer is simply a set of files and set of processes when computer is running. Same picture is with containers. Every container, when it is stopped, has only set of files on a hard drive of the Linux computer. When container starts, some of the processes are started in a Linux machine. And those processes interact via common Linux kernel. And they interact with resources like CPU, RAM, and network. And they may take some part of those resources. And please note that by default, Docker containers don't have any resource limits. And that means that every container may utilize up to 100% of all resources allocated to Docker Engine. And if you install Docker Engine directly on Linux computer, it means that every process in every Docker container may take up to 100% of all resources of Linux machine. If you use Docker Desktop on Mac OS or Windows and allocate some resources to Docker Engine, then those are the limits that could be utilized by every single process inside of every container. But of course, it's possible to limit resources for every container. And it is possible in Linux by using C groups, control groups. And you are able to say that, for example, container 1 may not use more than, let's say, 512 megabytes of RAM, or half of CPU, something like that. Alright, main idea behind all of that is that every container has own processes. For example, here in this container 1 there is single process, container 2 has also single process, and container 3 has two processes. But usually containers in Docker have single responsibility, single purpose. And that means that the best case is that every container is running only single process. For example, let's say that you want to launch Python application inside of the Docker container. And this Python application needs access to Redis database and write some records to it. Also, it needs to have access to mail server in order to send some emails. You could create a single container that will be running three different processes: Python, Redis, and mail server. But this solution is bad in terms of scalability and manageability. It's really hard to manage such kind of containers. And that's why it is much more better to create three different containers, one process per each: Python, Redis, and mail server processes. That is a single responsibility principle. And in such case, you are able to manage every container independently. You could upgrade every single container. You could scale containers and make, for example, 5 containers instead of 1 and create load balancing across different containers and so on. That's why main idea in Docker is that you should run single process per single container. Alright, that's how containers interact with resources on host machine. And this machine that is running containers is called Docker host. Next, let's proceed and let me explain you main components of Docker. And main components are actually Docker client, Docker host, and Docker server. I'll see you in the next lecture. Bye-bye. Let's proceed, and now let me briefly overview main Docker components. And afterwards I'll go through every of them in greater details. Alright, Docker client. Docker client is used for execution of commands on Docker server. And basically, when you open up terminal and enter Docker command, you launch Docker client. Next, Docker host. Docker host is used for launching and storage of containers. And actually, if you run Docker Desktop on Mac OS or Windows, then Docker host is small Linux virtual machine that is running on top of Mac OS or Windows computer. If you have installed Docker Engine directly on Linux computer, for example Ubuntu server, then this Ubuntu server is Docker host. Next, Docker server. There is actually no such kind of single Docker server. Basically, it is a set of different processes that are responsible for creation, management, and execution of different containers. And that is called Docker server. And for example, part of Docker server is Docker daemon. And Docker client connects to Docker daemon in order to send to it different commands, like Docker run or Docker images or something else. And those commands are executed afterwards by other processes at Docker server. For example, there are processes called containerd or runc that are responsible for creation and management of containers inside of the Docker host. That is a Docker server. Next, Docker image. Docker image is used for creation of Docker containers. It is read-only set of files, and you are able to create your own images or download already created images, for example, from Docker Hub. Docker container is running based on specific Docker image, and you are able to create multiple containers from the same Docker image. Next, Docker repository. Docker repository is a set of Docker images with different versions. And you are able to create custom repositories, you are able to use already published repositories, and so on. And place where Docker repositories are stored is called Docker registry. And most popular Docker registry in the world is Docker Hub. It is actually similar to GitHub. At GitHub you store Git repositories, at Docker Hub you store Docker repositories.